Picking up where we left off, let's do a few examples on finding projections. So we want the vector components of u along A, so that would be parallel to it, and vector components of u orthogonal to A, so that's the one that's perpendicular. So regardless of which one we're going to start with, both formulas require us to find the projection of u on A. And you'll recall that that's the dot product over the magnitude of A squared, and I times all of this by vector A. So let's start by finding the dot product of u and A. So that'll give me 8 plus 1 plus 6, which brings me to 15. Now, the magnitude of A squared is the same as going 4 squared plus negative 1 squared plus 2 squared, and we don't have to take the square root of it, because if we took the square root and then squared it, they would just cancel each other out. And so this gives me what? 16 plus 1 plus 4, which equals 21. So I have now that the projection is going to be 15 over 21 times A. So here's my projection of u on A. So that's 15 over 21 is my scalar multiple of 4, negative 1, 2, which is the same as saying that it's actually 5 over 7, because both 15 and 21 are multiples of 3, and I am left with the vector 20 over 7, negative 5 over 7, and 10 over 7. All right, well, if I then need u orthogonal to A, I just have to go u minus the projection of u on A, and so that's the same now as going 2, negative 1, 3 minus 20 over 7, negative 5 over 7, and 10 over 7. Well, if we're going to do this subtraction here, we really want to make sure that we're on a common denominator. So I would be going 14 over 7, negative 7 over 7, and 21 over 7 minus the projection we'd already found, 10 over 7. And we are left with negative 6 over 7, negative 2 over 7, and 11 over 7 as the vector that is the components of u orthogonal to A. Here we have actually vectors that are in R4, and we're asked to compute the angle between them and the projection. So we're going to need for both the angles, so I could write here angle. So cos theta will equal u dot v over the magnitude of u times the magnitude of v, and the projection of u on v will also be u dot v over the magnitude of v squared times v. So it makes sense that we should start by finding the dot product. So my dot product here gives me negative 1 plus 0 plus 0 plus negative 2, and so I have found negative 3. Let's find the magnitude of u. So that'll be the square root of negative 1 squared plus 1 squared plus 0 squared plus 2 squared. which is giving me 1, 2, and 4, so square root of 6. And also let's find the magnitude of v, which will give me 1 squared plus 0 squared plus 3 squared plus negative 1 squared, which is giving me 1 plus 9 is 10, plus 1 is 11, so square root 11. So with this information, I can say cos theta will equal negative 3 over square root of 66. So theta will equal cos inverse negative 3 for root 66. Okay, and then just as easily I can say, well, my projection of u on v will be that same dot product, negative 3, over the magnitude of v squared, so that'll just be 11, multiplied by v, which is 1, 0, 3, negative 1. So it is negative 3 over 11, 0, negative 9 over 11, and positive 3 over 11 for my final answer. Now, we also, though, want to remark that the formula for the length of the components can be obtained. So if I want to find, as we have right here, the magnitude of the projection, or the magnitude of this new vector that I found, what I'm actually asking for is the magnitude from the formula. And from there we can simplify. So we have, remember, a being the vector and it's being multiplied by our scalar right here. Well, if that's a scalar, we don't really find the magnitude of the scalar. We take the absolute value of it to make sure it's positive. And so I can take my absolute value of it, but I am finding the magnitude of the vector a. And as I simplify that, I can once again see that my denominator is squared. So I don't need my absolute value around my denominator because it's squared, because it'll always be positive. So then I just have my absolute value around my dot product. And so this then, when we have the magnitude of a squared in the denominator and the magnitude of a in the numerator, can once again be simplified to just this formula right here, where the magnitude of the projection is going to actually just be the absolute value of the dot product over the magnitude of a. So if theta denotes the angle, and we have the absolute, and we have that we can find our dot product with the magnitude of u times the magnitude of a times cos theta, then we can rewrite the above formula. So what we've done is taken this, plugged it in, and after that's plugged in, you can see that the magnitude of a will cancel. And in fact, if we know what theta is, so in the few cases where we know what the angle is between two vectors, then we can also find the magnitude of the projection by using that angle in this formula.